Ladies and gentlemen, today I will be teaching you all the basics of trigonometry. First of all, let us go through the learning goal. After this for the first part of the video, we will learn how to explain what a radian is and how it come to be. We will also learn how to convert a radian measure into a degree measure and vice versa. So without further ado, let's begin the first part. First of all, we will need to know that 1 radian is the equivalent of 57.295 degree. Now, most of us would not even bother to remember how many degree that it will equate to 1 radian. So to put it simply, a radian is the angle made by taking a radius and wrapping it around the edge of a circle. So for those of you who do not know, a radius is how the distance that we take for the center to touches the diameter of the circle. So basically, this is what a radian should look like. If let's say you just require about 1 radian, remember R does not stand for radian. It does not stand for radian. It stands for radius. Now, lastly, to put it simply, a radian is the pure idea of the radius being laid along the circumference. The circumference is also once again known as this. Now to illustrate it better, I will show you a GIF. Just wait for the GIF to load. Now look at how the wheel will turn, and every time it touches, it just moves half the distance, it will go to 1 pi and then 2 pi. And this is why we say that a cycle is always ends at 2 pi. For all the which will go to the primary trigonometry later. So 1 pi will also equate to 180 degree, and 2 pi will equal to 360 degree. Next, we will learn how to convert degree into radius. Let's just say that we have 200 degree. We simply multiply that by pi over 180 and we get 10 pi over 9 radius. That will give us 3.49 radian. Now to put a second example, let's just say that we have 129 degree. We simply multiply it by pi over 180. Now the formula is always pi over 180. That will equate to 2 pi over 3. Which would equate to 2.09 radian. Now for those of you who did not know, 1 pi is the equivalent of 3.14 or 22 over 7 in fraction. Now to put that from radian to degree, you simply need to flip the formula around, which is 180 degree over pi, and that will give you the answer of the degree that you require. Thank you very much. That will be the first part of the video. Ladies and gentlemen, and today we'll continue with our lesson. So we'll learn how to graph and describe the characteristic of the 3 primary trigonometry function and the 3 reciprocal function. First of all, we'll take a look at this graph. This is the 3 primary trigonometry function. Now we'll begin with sine. Notice that sine passes by the point 0, and it will only consider as a complete cycle at 2 pi. And the same case holds true for cos, because it will only be considered as a complete cycle once it passes 2 pi as well. Sine and cos is very similar, but except that sine will always begin at point 0 unless it is shifted in some way and transformed somehow, which we will get to that next time. Cos x would be you will always start at 1 and it will always end at 1. Now notice that the range of the two function is always y equal it's always 1 divided by y n minus 1. This will be the jurisdiction, and unless transformed, sine and cos will never go over this point. Now, for tangent, tangent is a much more interesting graph. Unless transformed, it will not have. It will always start at the 0 point, and there will always have a lot of vertical asymptote instead. Like here, there's 2 pi. We have a vertical asymptote that shift it in between. The range for it can go all the way up to infinite. As you can see in this video, they go a far way, my friend. So what happened to this is that why does this happen is that because wherever number was divided by tangent, they become unknown. They become so hence they head up all the way to infinite since they are an unknown number. Hello ladies and gentlemen, and we continue with our reciprocal function. First of all, there's secant. Now notice that secant, in all its basic, secant is 1 over cos pi. To prove this, we will activate this, and you can see that they are the exact same thing. See the color, how the color changes. Now secant, unlike sine, it begins with 1. It will always, the starting point will be 1, which is opposite of sine cos here, because as you guys can see that it touches 1 and it does not go above 1. And as for the bottom part, it's the same thing. It touches 0, but it goes on to all the way up to infinite. Infinite in the term of range. Now secant is almost basically sine. The relationship between secant is sine. Secant and cosecant is very similar to cos and sine, because they simply just move shit aside. And since they are very similar, cosecant is basically 1 out of sine. See, as you guys can see, that there is virtually almost no differences at all. Once again, you guys can see that it is basically the same thing. Next, we have cotangent and tangent. This one, even the name sounds very similar. It's basically 1 divided by tangent, and this is easier to remember compared to others because tangent is basically shifting, increasing towards the right side, while cotangent is more to increasing toward the left side. Hence, it decreases all the way down, but it works in a very similar way because the reason why this go up to infinite is because that we cannot find an unknown in this number, and hence these are the reciprocal function. Hello ladies and gentlemen, and for the last part of our video, we will explore what are the application of the trigonometry in real life. Now as you guys can see that there is this island, and assuming that we can simply assume the distance from the beach to the island by simply checking out on this trigonometry. Trigonometry is also commonly used to find the height of towers and mountains. And it can be easily used to find navigation of the shore from a point of the sea. As you know, it can easily help people to save life in general. It can be used in finding the distance between celestial bodies. Let's just say that what are the distance of, say, Saturn and Earth in comparison to the Sun. Now, how are function more important is that they are fundamental in theory of periodic functions, such as that to describe the sound and light wave. For example, like how fast light travels and how slow a sound or slow pitch is. And that's it for now. Thank you all very much.